Welcome to our educational channel from class 7th Maths ICSE board. Chapter 4 is decimal fractions. So previous chapter we discussed about complete thing about the fractions. Now when you come to this decimal fractions, so these are the topics I'll explain clearly one by one in this chapter. So if you go through this definition, you will see what is a decimal fraction and how to read the number, decimal numbers, and converting decimals to fractions and fractions to decimals. These two topics, and decimal places, how to identify, and addition, subtraction, multiplication, and division of decimals, and terminating, non-terminating of decimals, recurring and non-recurring, or recurring, repeating decimals, how to round off the decimal numbers, and significant figures. So some of you will get confused about what is significant and rounding off. Let us see the difference clearly, the topic one by one. Okay, first we will see that what is decimal fractions. Okay, decimal fraction or a decimal number is a fraction whose denominator can be expressed as 10. If we can express denominator as 10, for example, 7 divided by 10. Now this is the decimal fraction because 7 divided by 10, we can write 0.7 because 10. Any fraction whose denominator can be expressed as the 10 or some power of 10, not only 10, even if you take 8 by 100. So this is 0.08 because after 0.2 decimal places because of 2 zeros, 10 to the power 2. So these all are decimal fractions, 7 by 10, 8 by 100, and let us take 3 by 5. 3 by 5, if you observe, denominator is not 10, but we can make it as 10. How? Divide, multiply with 2 numerator and same denominator multiply with 2. Then 3 into 2, 6, 5 into 2 is 10. So we expressed denominator as the 10. So 3 by 5 is a decimal fraction, right? Or decimal number. We can say it is a fraction, but 3 by 5 is the decimal fraction. So a decimal fraction or decimal number is a fraction whose denominator can be expressed. Denominator can be expressed as 10 or power of 10. Higher power of 10, like 10, 100, 1000, 10,000. So any number of power of 10, right? And even let us take 7 by 8. Now 8 into dash is, we'll get power of 10. So 8 into 125. 125. Same number should multiply and divide. 7 into 125 is 875, but this is 1000. So that means we can say 7 by 8 is the decimal fraction. So we can do divisions, that is secondary. I'll show in the concepts we're doing one by one. Main thing, what is decimal fraction or decimal number? Means if any denominator, if we can express as the 10 or power of 10, so that is the decimal fraction, right? And these all we can express. Now this is 875 by 1000, so 0.875 because 3 decimal places. So this is we can express. So in order to give a decimal fraction in shorter form, this denominator we can express in this way. So even like 59 10 to the power 4 is the question. So 59 by, after 1 4 zeros, 10 to the power 4, 10 should be multiplied 4 times. 59, but these are 4 zeros, so 10 to the power 4 it is. So keep more 2 zeros and keep the point. So these all things systematically one by one we will see. And most thing expressing, returning, like decimals to fractions, fraction to decimals. So even addition, subtraction, multiplication, divisions. So all we'll see one by one. Reading the decimal number. Even higher class students also will get confused how to read the decimal numbers. So in this class 7th only we need to learn clearly when you are reading or when the questions are giving the examination or while writing on the paper notebook. So we need to read according to the proper order. So the integral part and we have the decimal part in this. For example, let us take one decimal number 63 and 43. So 63 point, this is 43. In this left side of the decimal point is the integral part. Okay, and decimal part is right side of the point. This side we should read the digits, each digit in order separately. So this is 63.43. So should not read 43. That is wrong. Okay. And see some examples. 21.45 it is, not 45. 21.45 and 153. This side and other side is 63. That means it is not 63, 063. So 153.063. That means the decimal part, each digit in order separately we have to read. So you have to read by naming the each digit 063. We have to read in this way. Even some examples. Okay, this is the number now. So we have to read this 0.08. Okay, all 0.08 or 0.08 both are same. 0.08 or 0.08. Generally you can read as 0.08. If there is no before the point, we can keep the 0. Okay, and here is in decimal system, the first place of the right side of the decimal point is 10th. Now this is the 10th. The 10th place, and this is 100th. So places we are studying in previous classes also. 10th, 100th. Normally integral part we know that ones, tens, 100. 3 is in ones, 5 is in tens, 1 is hundreds. But after the point 10th, 100th, 1000th we need to take. So because let us take one example. 21.63. This we can write 21 plus actually 0.6 plus 0.03 it is, because after point one decimal, after point second decimal. That means 21 plus this is a 6 by 10 we can write. This is 3 by 100 because you know previous, right? 0.03 is 3 by 100. That's why 6 is the 10th place. Tenths. So 6 tenth, 300th. That's why after the point first number 10th, next to 100th, next to 1000th, so on. Okay, similarly first on the left side decimals is units, tens and hundreds. We know that already. So this is the way we need to read out, right? For example, see one more example, 5.46. So in this number 5.46, 5 is the units place, 4 is at 10th place, and 6 is at 100th place. Okay, this is the order, and we need to read the after the point every digit. We have to, by naming each digit, we need to read any bigger number you take. Now 616 point. Okay, this is the number. So we have to read this left side of the point 616. Like this normal integral part, and right side is 616.3246. We have to read each digit separately, right? Converting a decimal number into fraction. So this is very simple. Let me take one question here. For example, 0.27. So this is a decimal number. To convert into fraction, removal of decimal number. So this decimal point we need to remove first. From this, remove this decimal point 0.27. So if I remove that point 0.27. So 0.27 is nothing but just 27 it is. Okay, there is no meaning. You can keep the before the number. So 27. Then after the point, just removal of decimal point from the given decimal number, and in its denominator write as many zeros as the number of digits in the decimal. So after point there is a 2 decimals. So after 1 keep 2 zeros. So as many zeros as the number of digits in the decimal part to the right of the 1. Then simply, if it's possible, just you can make into lowest terms. 27 by 100. If it is possible, make into lowest terms, or else there is only the answer, right? Anything, just like 3.64. So this we can write, remove the decimal point. So 364. Just keep divided by 1. After the point, 1, 2 decimal places. So you can keep the 2 zeros. So 364 by 100. Compulsory you can make into simplest form because its possibilities. 27 by 100 is not no common factor. 364 by 100. You can simplify, cancel with 2 table. 2 5 is a 10, 0, and this is 2 1 8 2. More you can cancel, right? 2 table. 25 is a 50. This is 9 18 1 91. So 91 by 25. 3.64 value is 91 by 25. You can write in mixed fractions. 316 by 25. Okay, that is the converting to decimal number to fraction. Even 0.0024 is there. So just will write 24 by. So don't take 0.0024. 24 divided by after the point number of decimals. Even this also should be counted. Total 4 decimal places after the point. So after 1 you write 4 zeros. Then you can simplify this. 24 by 10,000 we can cancel with 2 table. Okay, that you can do it. And just to make it simple, 12, and it is 5,000 in 2 table cancel. 2 6 is 12. So 5,000 is 2,500. More 2 table you can cancel 3 times. So 1250. 3 by 1250. 3 divided by 1250. So 0.0024 value is this. And so on we can make. That means removal of decimal point from the given decimal number and in its denominator write 1. How many decimal places are there? That many zeros you can keep. And if it is possible, make into simplest form. So we did simplify. Okay, this is the converting. Just any decimal number is given, fractions we can convert. Let us see fraction to converting decimal numbers. Converting a given fraction into a decimal fraction. So any fraction is given, how to convert it to decimal number or decimal fraction. So we have two methods. First one, when the denominator of the given fraction is 10, 100, 1000, so on. That means, for example, 259 divided by 10. Okay, so in this case, this is the fraction to convert into decimal number 259 by 10. So there is only one zero. So counting from extreme right to left, mark the decimal point after as many digits of the numerator as the zeros in the denominator. So 10 it is. So from the right side, so 25.9. 259 by 10 is 25.9. Okay, let us take one more in this same number. If it is 259 by 100. Okay, so this is, should write 259, two zeros, right? From the right side, 1, 2. Leave the 2 digits and keep the point. So 2.59. If it is a 3, 259 by 1000. That is 0.259 because 3 is zeros. So from right side, you can take 1, 2, 3 places. So 0.259 and so on. In case if it is more, 259 by, let us take 4 zeros it is. So how to write? Now let us take this 259 from right side, fourth place. All it till here is 1, 2, 3. Again fourth place is not there. So keep 0 and point. Keep one more 0 before that. So 0.0259, that is 259 by 10,000. So this is the converting when the denominator is 10, 100, 1000, so on. Apart from this, further examples, for example, let us take 15 divided by 4. These type we can do normal division. So when denominator of the given fraction is other than 10, 100, 1000, so on. So we have to do division normal method. 15 divided by 4 you do. Okay, 4 table. So 4 3 is a 12. 3 normal. So when you keep 0, because there is nothing to take down, put 0 and keep the point. Right? Again 3, 4 into 7, 28. Subtract 2. Keep 1 0. 1 0 you can keep. Again 4 5 is 20 0. So 3.75. This value is 3.75. So on. So any normal, like divide in ordinary way and mark the decimal point. So in this number. So if it is the denominator is 10, 100, 1000, 10,000, so on, you can adjust the point directly. or else we can do normal division method to converting given fraction into decimal fraction. Decimal places. So when you see this decimal places, actually number of figures that follow the decimal point is called number of decimal places. Okay, let's take one example. 6.32. So after the point, number of figures, there is a 2 are there. So decimal places, that means number of decimal places is 2 here. Okay, in 6.32, it has 2 decimal places. 2 decimal places in this. So it is only after the point. Okay. Now, for example, 28.497. So after the point, 3 figures it is, 3 numbers, so 3 places. So it has 3 decimal places. So decimal places is after the point number of figures. There is a number of decimal places. So based on this, we have the 2 types. One is the like decimals, unlike decimals. So like decimals, and one more is unlike. So like decimals and unlike decimals. When you come to this 2 names, like decimals is which is having same number of places, same number of decimal places. Same number of decimal places means, for example, 3.9, 8.7, 4.2, okay, 132.4, etc. So after the point, equal number of figures, that means only one it is, so one decimal place. So these are all like decimals. Okay, even take 2 others, 9.45, 2.43, okay, 6.41, so on. So these examples come under like decimals. Okay, decimals having the same number of decimal places are called like decimals. Now when you come to the unlike, different it is, same. So decimals having unequal number of decimal places. Okay, 42.3 and 6.34. So here is one decimal places, set 2. Okay, 7.216. 1, 2, 3. So different number of decimal places. So these examples come under unlike decimals, right? And we can make into like unlike decimals to even like decimals also. Okay, there is no difference. For example, only if you write 5.4, right, and one more is 3.42. 5.4 and 3.42 is unlike decimals, but 5.4 we can write 5.40 also. So any number of zeros we can put at the end after the point. At the end we can keep any number of zeros, value does not change. 5.4 and 5.40 is same. So 5.40, 3.42 are, these both come under like decimals. But when you see these two, unlike decimals. But when you are writing, this is the difference. Okay, there's the only difference. Just remember, like this decimal places is after the point number of figures that is come under decimal places. Addition of decimals. In general, normal additions how you do. Same way even decimal numbers also will do, but most of you confuse on addition of this. The simple technique is we need to keep the decimal point should be same all the numbers. For example, 3.92 plus 11.057 plus 236.84. If you want to add this number after the point, so this is 2 decimal places, 3 decimal places, 2 decimal places. So we need to write in vertical 3.92. So under the point, same point should be remaining 2 numbers also. Okay, remember that one. So this is the 11.057. 057 is right side, 3 numbers. Left side is 1. Okay, the places are empty, you can see. So here is in this the place is empty, and this 2 also. Right? That means those places empty, let it be. If you are still confusing, just you can maintain 0 because the end of the point, after the point ending, any number of zeros you can keep, right? And here 236.84. So 236. So after the point and before the point, that number should be on the same line. So point should be same as it is. Under the point we should keep. So the decimal point of all the numbers fall on the same vertical line. Then we can do addition. This is normal way. Okay, when you are getting confusing, just these places you can fill with zeros. Not necessary. We can see because vertical line way we need to add this, right? Now it's a 7, 2 plus 5, 7 plus 4, 11. So 1 carry, 9, 18, same 1, 8. So again same under the point, point will come here, right? 7, 8 and this 3, same 3 plus 1, 4 plus 6, 10, 11. 1, 4, 1, 5, 2. So answer is 251.817. Okay, the main thing is writing in vertical under the point, the number should be clear. Okay, this is the main thing. Or else you can convert the everything into like decimals also. Okay, same number. Let us see one more example. 6.3 plus 3.2 plus 0.16. So here is one decimal place, two decimal places. You can make into like terms, like decimals. So 6.3, 3.2, 0.16. So convert into like decimals means extra two zeros. So 6.30, 3.20, 0.16. You can do addition. 6 and this is 6.9, 9.66. Okay. Any whole number can be expressed as decimal number by putting the decimal after that. Okay. This is the addition of decimals. In case like normal numbers, for example 15 plus 2.5 plus 12.05. when you want to add this, 15 is a whole number. You can also this expressed as the decimal number by just putting decimal after the last unit digit. So it may be any number of zeros. We can write this is from this 15, no, 15.0 you write. Next is 2.5, 2.5. Next is 12.05. So point should be same place. Right side is 0.5, left side is 2, 1. Okay, 1, 2. So 12.05. Make into like decimals. Instead of confusing, if you want, just keep two zeros. You can engage the zeros, ending or starting. Don't keep in the middle. And 5.92, right? 29.55. Okay, just two methods. Directly, if they'll give decimals, you can keep, or else convert into like decimals. If any whole number is given, make into decimal number. After the point, keep any number of zeros. Okay, this is the addition of decimals. Same way, let us see subtraction and multiplication, division of decimals also. Subtraction of decimal numbers. So to subtract this decimal numbers, even in subtraction also same like numbers are written in such a way that their decimals are in same vertical line. Okay, for example, let us take one question. Subtract and 5.27 from 13.89. Okay, you need to subtract 5.27 from 13.89. So these both are like decimals. Okay, same two decimal places. Now from 13.89, so take 13.89, we have to subtract 5.27. 5.27. When you're writing the numbers, same place value. So 3 is in units place. Under that 5 is units place. 1 is in tens place. So place value should be same even along with this point. Then do normal subtraction. I will do 1389 527. Same way 13.89 minus 5.27. Don't see the point, just normal subtraction you can do. When the place is coming with point, you also keep the point, right? And 9 minus 7. So it's 2. 8 minus 2. 6. So even this is a 6. Even carrying also same type. 3 minus 5. So it's not possible. Take carry here. 13. 13 minus 5 is 8. Okay, 8.62. Subtraction. Let us take one more example. For example, we need to subtract 0.84 minus 0.8. Small mistake. Okay, so let's take here 0.5. Then place value is same. 8 is your 10th place, 5 is also 10th. Now this place is empty, you can put 0. Right? The question is subtract this number 0.5 from 0.84. So 0.84 minus 0.50. Then subtraction, take normal subtraction. 4 minus 0. 4, because there is no place. So you can keep the 0 now, because make it as like decimals. 8 minus 5, 3. 0 minus 0 is 0 here. So 0.34, right? And some questions we need to combination, because we did previous addition, right? Along with that, addition and subtractions together, evaluate. Let me take one question. 11.349 minus 5.57 plus 9.28 minus 12.6. So to find out this value, positive values and negative values are here. So let's write positive numbers together. That means 11.349, 11.349 it is. Next, plus 9.28, 9.28. These both are positive numbers. Write together. Next, minus 5.57 minus 12.6. So from this both, you can take minus common. Either both are negative numbers, you should keep negative sign and we need to add again, right? So 5.57 plus 12.6. 12.6 it is. Okay, now 11.4349 we can convert into like decimals. You can keep 0. Here 2 decimals, no, one more 0. Just 0 you can keep. So convert into like decimals. 11.349 plus 9.280. By adding this both normal, we'll get the answer 20.629. Okay, 9. Normal addition you can do. Keep minus symbol and add these both also. 5.57 plus 12.6. So 0 we can write. Right, 2 decimal places. And that is 7 0. So 7 it is 1 1 8. So 18.17. 20.629 minus 18.17. Just take this 20.629 minus 18.17. So here is place is no, keep 0 and do subtraction. Okay, 9. 2 minus 7, take carry. This is 5 becomes 12. 12 minus 7 is 5. 4, same point. 20 minus 18, so 2 it is. Okay, this is 1. It is 10, right? 10 minus 8. Subtraction is normal again, you can do as it is. So that is 2.459. So this is the answer. Even addition and subtractions together also, main thing is convert into like decimals, then you can go for addition or subtraction, be easy. Multiplication of decimal numbers. So when you see this multiplication of decimal numbers, we have total 3 types, 3 categories we can say. One is multiplication by 10, 100, 1000, so on. Any decimal number, how to multiply it by 10, 100, 1000, so on. Like power of 10. You can see example. 3.2985. this is the number 3.2985. So when you multiply with 10, when you multiply by 10, so here is this decimal point should take to right side one place. So we are multiplying with only single 10. That means only one zero. It's a power of 10 to the power 1. So the answer is just this decimal place will come to one place right side. So simple. Shift the decimal point in the multiplicand. So answer, right? To the right side, right? By as many digits as there are the zeros in the multiplier. So as many zeros, how many zeros are there? That many places you can take right. So 32.985. Small change. 985. You can take this. Now next same way. One more example you take. 3.2985 multiply with 100. So the decimal place will be two places. That means 329.85 and so on. Any number you can take. Okay, this is one category, one type. Decimal number multiplied by 10, 100,000, so on. As many zeros are there, that many places the digit point we can take to right side from this point onwards. Okay, next one, multiplication by whole number. So any number is any decimal number, multiplication by whole number. For example, 0.3 multiplied by 6. 6 is a whole number. So without considering this point, that means multiply in ordinary way without considering the decimal point. Without considering this decimal point, this is just a 3. 3 6 are 18. Now you can check how many decimals after the point. Only one. So from the right side, you can leave one digit and put the point. So 0.3 into 6 is 1.8. See one more example. Let us take 0.26 is multiplied by 18. It's multiplied by 18. Now 0.26 multiplied by 18. So here 26 without considering this point is 26. 26 multiplied by 18. So that is 468. 468. Then this place after the point we have 1, 2, two decimal places. So from right side 1, 2 you can leave. From right side only. Two decimal places you can leave and keep. So 0.26 into 18 is 4.68 and so on. Okay, this is one way, multiplication with whole number. And one more category is any decimal number is multiplied with another decimal number. Okay, see example. Let us take 0.2 is a number multiplied with 0.4. Now without considering the point, it's a 2, this is 4. 2 4s are 8. Now you can keep the decimal places. Here is a 1 decimal place, 1. Total 2. So 2 decimal places from the right side. Only 8 is there. So put one more 0 and keep point. 0.08. Okay, see one big example. Let us take 2.3 multiplied by 0.6. Right? Now 2.3 into 0.6. So without decimal place, just that is a 23 and this is 6. Just to multiply with the ordinary way, normal method. Okay, 6 into 3 is 18 and carry 6 to is 12 plus 1 13. So answer is 138. But now after the point one decimal here 1 total 2. From right side 2 decimal place you can leave and put the point. So 2.3 into 0.6 is equals to 1.38. Okay, any number, even one more example. Let's take 2.895 multiplied by 1.1. So 2895 multiplied by 11. Normal method is multiply you get 31845. Then just adjusting the point. After point here 3 decimals 1, total 4. So total 4 are there. So 3 plus 1, total 4 decimal places you have to leave from the side. Okay, total we have. So this is the way we can multiply two or three categories. One is with 10, 100,000, as many zeros are there, that many points you can shift right side. And with whole number, with the decimal number, same number of decimals you have to count and adjust in the multiplicate in answer. Let us see how to divide the decimal numbers now. Now let us see how to do divisions of decimal numbers. So same concept will apply in the multiplications, even decimals also. We have in three types. First one, division by 10, 100,000, so on. Any decimal number is given, dividing with 10, 100,000, so on. Okay, let us take one example. 623 point, let us take 42, divide by 10. Okay, to find this answer, when your multiplication, point should shift to right side, right? When you're doing division, that point, that means the shifting the decimal point one is to the left, because there is a 1 0. As many zeros, that many places left side you have to shift. That means answer is 62342. So this decimal place shifted to the left side. So 62.342 divided by 10. See one more example. Same number 623.42. If it is divided by 100, so in this case this decimal place shift to two places because of division with 100. So that is 6.2342. Okay. N number of zeros, that many places is point should shift to back, so left side. Okay, see another example. Let us take easy one. Okay, 2.3 and divide by, let us take 1000. In that case, without decimal, this number is 23. Now this place should shift to left side three places. Up here is only one, but no more two places. So you can keep in mind another two zeros. So extra two zeros if we keep. So this should shift here. So 0.0023, because up here is 1 and 2, then 3 because of three zeros. 0.0023, right? This is the division when 10, 100,000, so on. Same way, uh, one more is division by whole number. Let us take one example, dividing the whole number. 16.952 divided by, let us take 8. 8 is a whole number. Now do division this. Normal division you can do without considering the point. Let us keep the point, but normal we'll do division. Same way we'll do this. Skip 8. Same 8 table. So 8 to the 16, right? 0. Now when you take the decimal, when you take the number after the point, you also keep the point here. There's only a change, right? Divide the normal manner, ignoring the decimal, and mark the decimal point in the quotient when just crossing over the decimal point in the dividend. When you cross this, keep the point here. 9 it is. So 8 times 1 is 8. 1, 5. Right, same. 8 times 1 is 8. Subtract 7. Next place is the 2. So 8 9, so 72. 0. Only thing is when you take the digits after the point, keep the point here also in the quotient place. Right? Any example? Let us see one more example. Okay, if it is a 0.945 divided by 9. So what we should take here is a 0 it is. So 9 zeros are 0, right? But when you're taking this after the point 9, so immediately you have to keep the 0. So 9 times 1 is 9. So 0 point. Next 4, 5. 4 is only one digit. Take one more digit and put point. 9 5 is a 45. Normal divisions only, but when you're taking the digit after the point, you also keep the point in the quotient. Okay, this is one. And one more case, when it is a decimals divided by decimal number. Okay, division of decimal number by another decimal number. Okay, let us see one example. 4.8 divided by 0.8. That means 4.8 by 0.8. So in this case, at least denominator we should make it as a whole number. Denominator after the point is one decimal. So we can multiply 10 by 10 because after the point is one decimal. 4.8 into 10 is 48. 0.8 into 10 is 8. 48 divided by 8. So 6. 4.8 divided by 0.8 is 6 only. See one more example. Okay, for example, 5.625 divided by 1.25. So in this dividend place, this numerator and denominator. Denominator we have two decimal places. 5.625 divided by 1.25. If we don't want to multiply with 10, 100 and so on, just a simple technique is this point you can shift to two decimal places, numerator and denominator. So value does not change. Now this becomes 562.5. This is 125. 5.625 becomes 562.5. 1.25 becomes 125. Value does not change. Do normal division now. Take 562.5, divide with 125 now. So it's simple. So 125 4s 500, 62 5. So after the point I took again. After subtracting, next digit I took. So you also keep the point. 125 times 5 is 625. So 0, 4.5. Just only denominator you can make it as a whole number, and same logic you apply when division with whole numbers. Okay, this is the method you can follow when we division of decimal numbers. Terminating and non-terminating decimals. So let us see these two terminology and what is the difference between them. So sometimes in the division, dividend is exactly divisible and no remainder is left after certain number of steps. That means if you get the remainder is 0. So those examples come under terminating. But when you come to these terminating decimals, you can let's say take one example, 31.76 divided by 4. So after doing certain steps, we should get the remainder is 0. Now those examples is a terminating decimal. Right now this is a 31.76. Let us check with divide by 4. Here is 4 table, 31, 7 times 28, subtract 3. When you take after the decimal, you need to keep the point. Okay, previous topic we discussed that. And same, 4 table, 9 so 36, 1, again 6 is down, 6, 4, 4 so 16. After certain steps, now completely we got the remainder is 0. So there is no remainder is left after certain number of steps. So such answers in the quotient are called terminating decimals. So this is the quotient, right? So 7.94. So this is the terminating decimal. So 31.76 divided by 4. We got this. And that means such answers in the quotient. We got 7.94, right? This is called the terminating decimal. Now same opposite for non-terminating. When you come to this in certain cases, while dividing, the remainder does not finish. So no matter how long the division is continued. So it does not finish. Let us take one example for this non-terminating. 13.78 take divide by 7. Okay, let us do division and check. Now here is 13.78 divided by 7. 7 table. 7 times 1 is 7. Subtract this is 13 minus 7. 6. Take the digit after the point, keep the point. Okay, 67. That means 7 times 9. 63. Subtraction is 4. Next 8. So here is 7, 6 are 42. Remainder is 6. There is no more number to take down, just you can keep 1 0. 60. Again check this 7 into 8. Okay, 56. Because 7 into 9 is more than 60. Subtraction is 4. Again 0. Right, 7 5s are 35. Subtraction I got again 5. And so on. If you take 50 again 7 7s are 49. 50. 7 into 7 49. We got again 1. We get again 1 0. So that means it's so on, it's continuing. In fact, that is the non-terminating decimal is shown by writing the digits of the quotient till the division is carried out. So 1.96. So it's continuing this. So we should not, there's no remainder is 0. We did. Even if you continue more, for example, you keep one more 0. So 7 times 1 is 7. We get 3. So it will be continuing. So these type examples come under non-terminating decimals. After doing certain steps, we got the 0, but it's not 0. So these examples come under non-terminating. Same way, even in non-terminating, we have one more type, recurring or repeating decimals. We'll see now. Continuation of non-terminating. What is recurring or repeating decimals? Here we'll see recurring or repeating decimals. So in non-terminating decimals, non-terminating means the remainder does not finish. So sometimes on performing the division, so you'll find the same remainder is left no matter how long the division take place. Okay, see for example, 2 divided by 3, not decimals, just if you can take the number 2 divided by 3. When you do this 2 divided by 3, 2 is smaller than 3, just keep 0 and point. 3, 6, 18, subtract 2, put 1 0. Again 3, 6, 18, subtract this, put 0. Okay, 3, 6, 18. It's again subtraction is 2. So it continuation. This also continue. So this answer is 2 divided by 3 is 0.666 so on. So instead of writing the 6 infinite times, just we will use 0.6 small hyphen will keep, which is repeating on that. So only 6 is the repeating. Or even some books you can use in keep the small dot also. Both are same. 0.6 the dot or hyphen you can keep. So which is a non-terminating repeating decimal. It is a non-terminating, but again it is a repeating. So these are called recurring decimals. Non-terminating and repeating. So recurring decimals. So dot or bar shows that 6 repeated infinitely, right? Let's take one example. 15 divided by 22. Okay, if you do this calculation, you'll get 0. I have done already. Just I'm showing the answer 68181, so on. So this 8181 will be repeated. Two digits are repeating in this. That means you can write 0.681. First time only you can keep. Don't write one more 81. 681. 81 is repeating. Or else same thing we can write 0.681. Two dots on, one dot is on 8 and one more dot is on 1 you have to keep. Okay, these are the recurring, that means non-terminating repeating decimals. We have to continue. Now conversions. Let us see how to convert this type of repeating decimals to the into the fractions or vulgar fraction. That means numerator by denominator. So we have two types. One is a pure recurring decimal, mixed recurring decimal. Pure recurring decimal means after the 0, complete decimal part should be repeated. And mixed recurring means after decimal, only some part is repeated. Okay, here is a, for example, 3.060606 is repeating. So after the decimal, complete decimal part is repeating. This is the pure recurring decimal. Instead of that, only 0.3.06, only 6 if it repeats. After that point, 0 is not repeated, only 6. So this is the mixed recurring decimal. Okay, when you come to this pure recurring decimal, it is a decimal number in which all the digits in the decimal part is repeating. And we come to this mixed, it is a decimal number in which all the digits in the decimal part are not repeating, only few. Right, now let us see conversions, how to convert this non-terminating repeating decimals into vulgar fraction with example 0. Let's take 234, right? 4 is repeating, so this is the mixed recurring decimal. Now this how to convert into vulgar fraction, means convert it to p by q form. So we have the two steps, numerator and denominator. So numerator, what we should write is just enter the number without the point, without this recurring, just write the number first, 234, right? From this subtract which is not repeated, entire number you write without point, without hyphen. From that subtract which is not repeating, not repeating is 23, that is the numerator. And denominator is how many digits are repeating, that many nines you keep. Here is only one digit is repeating, so 19. After the point, how many are non-recurring, which are not repeating, as many zeros you have to keep. Okay, 234 minus 23 by 900. So this is 211 by 900. If you do division, you'll get again 0.234 hyphen. Same answer. Let us take one more example. Okay, 0. Let us take 234. Hyphen is on 34. Now this answer is 234 minus 2 we should take. Because which is not repeating is only 2. Entire number minus non-repeating number. Divide by how many digits are repeating? 2 digits. So 2 nines. After the point which are not repeating digits is 1. So 1 0 we should keep. Right. This is a 232 by 990. We can simplify this. 232 by 990. 2 table we can cancel. 116. This is 495. So 116 by 495. Right. Even same example, for example 0.234, all the digits are repeating, so this is the pure recurring decimal. It means entire number you can write minus 0, there is nothing, means just 0. And 3 are repeating, 3 nines, there is no 0 again, everything is repeating. That means 234 by 999. If you do division, you get the same. Okay, previous example also observe, 2 divided by 3 is 0.6. Okay, now how to write this one? 6 as it is, divide by how many digits are repeating? Only one digit, right? So 9. 6 by 9. 6 by 9 you can cancel 2 table. 2 3 is a, and this is 3 table you can cancel. 3 2 is a, 3 3 is a. So 2 by 3, right? Same we got 2 divided by 3. Anything, even with the mixed also we can make it the same. So this is the method when it is non-terminating repeating decimals to convert into the vulgar fraction. Rounding of the decimal number. So instead of getting confusing, just in short way I'll tell you how to do exactly. Sometimes the numbers are found up to larger number of decimal places, right? Okay, say for example 3.481 or else 8.66. Let's say bigger number 7281. Any example 5.36142 and 9.63721, so on. So we need a bigger number, that means up to larger number of decimal places. So we need to simplify this up to 1 decimal place or up to 2 decimal places. So depending on that, we have the simple technique. First one, if the answer is required to correct to 2 decimal places, we take the digits up to 3 decimal places. For example, this is the number. If you want to make correct to two decimal places. That means after the point there should be third digit also. Now 3.48. So see the third digit. If you want to correct to two decimal places, the third decimal place is 5 or more than 5. Then the digit in the second place should be increased by 1. The digit in the third place is less than 5. So you can keep, we will not change anything. Okay, now third place is 1. This is less than 5. So only 3.48. Okay, now this also I am going to correct to two decimal places. If you want to two decimal places, third digit you need to check. If you want to correct to two decimal places, after the point 1, 2, 3, 4, 5, 6 decimals are there. Now the question is correct to two decimal places. If you want to correct to two decimal places, after the digit, after the point, see the third decimal place is 7. So 8.6. If the third place is 5 or more than 5, even 5 also. 5 or above 5, the number is, now 7 is more than 5. 5 and more than 5, like 5, 6, 7, 8, 9. Now the previous digit should be increased 1. So it becomes 7. So 8.667281 correct to two decimal places 8.67. Okay, see these ones. This is just only 5.36 because third decimal place is less than 5. Okay, in this number 9.64 you should keep because third place is 5 and above. 5 including 5 also should consider. Okay, these things to remember. Now connect it to two decimal places. Any number of decimal places is the same. Okay, few more examples. Now 4.78 or let's take 738. Now this is equals to 4.74. This is correct to two decimal places, right? Correct to two decimal places because third place is 5 and above because 8 it is. Next, same 4.738. I can write only 4.7. This is correct to one decimal place. One decimal place. One decimal place means second digit. You have to check. Second digit is 3. 3 is less than 5. So same as it is, you can keep. There is no change. Now if it is 4.738 is equals to, we can write 5. This is the correct to nearest unit, not decimal places. Correct to nearest unit. Nearest unit means just see after the point, first digits itself. First place itself is 5 and above, increase the previous number. It's a 5. So correct to nearest to tens, nearest to hundreds, those we did already previous chapters. Now this is a correct to nearest decimal places. And then you can take nearest to whole number also they'll mention. For example, 73.52. This is correct to nearest to whole number. Nearest to whole number means after the point, if it is 5 and above, increase the previous. So it becomes 74. Okay, now this is the correct to nearest to the whole number. Whole number means there's no decimals, right? Just think you remember 5 and above. 5 or more than 5. Just 5 or more than 5. If it is there, you need to increase. Less than 5, it will be retained the same. There is no change. Okay, these are the things rounding of the decimal numbers. And significant figures is different. I'll show that now. Significant figures in this digits, how to find out exactly correct to one significant figure, correct to two significant figures. Same like decimal places, but small change we need to know in this. So significant figures are the total number of digits present in the number except the zeros preceding the first numeral. That means, let us take one example, 0.0506. Now this is correct to one significant figure. One significant figure means from the starting zeros will not count. First number is 5 itself. So this is 0.0506. 0 5 because next place is 0, it's less than 5. So this is the correct to one significant figure. Correct to one significant figure. So come same like decimal places. We'll proceed in the way same similar to the used for the decimal places, but you can take only the numbers. And say for example 0.36089. If you want to correct to one significant figure is the first digit is 3, but after 3 next number is more than 5, 5 and above. So we can write 0.4. This is correct to same one significant figure, right? And say few more examples. Let's take 0.6079. So if you want correct to two significant figures, starting zeros is not counted, two significant figures directly 1 2 6 0. So here is a 60 means third place is more than 5 and above. So 61, that means 0.61 is the correct to two significant figures it is. Even if you take number, let's take one example 7.04870. If you want to correct to three significant figures from the starting 1 2 3, three significant figure means from the beginning you have to take the three digits. Now that is 7.0. You can check this next place, it's 8, 5 and above, so you should increase this, right? Now this is correct to three significant figures. Same from the beginning we'll see. And for example 14.08. Now question is find a correct to five significant figures. Five significant figure means already 1 2 3 4 only are there. So fifth place is not there, just attach the 0. 14.080. This is correct to five significant figures. Okay, decimal places means that is the previous one. Correct to two decimal places, correct to three decimal places. Only the decimal part will see. Will not see this starting integral part. When you can come to the significant figures, even integral part also just counted. Okay, anything. Let us see one more example. 12.864. So correct to three significant figures. So first three, that is 12.8. But see this fourth place, it's 5 and above. That means we need to take instead of 8, we should take 9. So this is correct to three significant figures. 1, 2, 3, right? This is a small difference regarding significant figures and rounding up the decimal numbers. Decimal numbers only the decimal part will see. Significant figure including the integral part and decimal will consider from the starting. Only not consider if the zeros are at the starting. Beginning with zeros will not counted those. Okay, here is 0.050. We'll start with 5 only. Okay, one significant figure only starting with 5. Next place you are checked. Right, this in between middle zeros will be counted, but starting the zeros only will not consider for the significant figures. Right. Okay, these are the topics from these decimal numbers. So I can go one by one in order to learn the topic clearly, and you can find the link some description below about the material of this class, including IT Foundation. You can go through that.